In the Feynman-Stueckelberg diagrammatic convention, an antiparticle is represented as a standard particle traveling against the time coordinate. As a mathematical rule, this is brilliant. Reversing the time orientation of a fermion line simplifies the calculation of perturbative amplitudes in quantum electrodynamics. But an efficient calculational rule is not a description of physical ontology. Physics education routinely makes a specific category error. It takes a highly effective mathematical map and assumes it is a photograph of the underlying territory. Time is not a source-level dimension through which objects can move in opposite directions. There is no physical mechanism rewinding a subatomic clock, and there is no literal anti-universe running in reverse. The positron is not an electron moving backward through time. It is a charge-conjugate projection polarity embedded within a single non-temporal source architecture. Before antimatter became a generalized theoretical concept, it was an isolated empirical anomaly, a track in a detector that refused to fit existing classifications. In 1933, Carl Anderson identified a particle track behaving with the mass scale of an electron, but deflecting in a magnetic field exactly as a positively charged object would. Physics scrambled to categorize it. Paul Dirac proposed Hole theory, interpreting unoccupied negative energy states as positive energy particles, bridging relativistic consistency with new empirical data. Decades later, Richard Feynman formalized the modern space-time perturbative map, fully adopting the time-reversed line convention to manage the mathematics of quantum fields. To correctly interpret this history, we must establish a rich boundary between two concepts. Operational time is the sequencing parameter used by laboratory clocks and detector gates. The foliation index, denoted as lambda, is the purely structural label assigned to how quantum states are sliced and compared. When physicists test discrete symmetries like charge, parity, and time reversal, the C, P, and T in the standard model, they are testing operations within the formal map. A T transformation alters the equations. It absolutely does not dictate that the physical universe has a rewind button. To understand the positron, we must first correct our definition of the electron. An electron is not an independently self-contained three-dimensional bead. This diagram illustrates the primary projection geometry. A non-temporal, higher-dimensional domain called counterspace holds the full structural content. It casts data downward into the three-dimensional observable plane we call the shadow domain. The node you see here represents the deeper source-level lepton relation. It exists entirely independent of our observation. Under this formal pullback equation, that source relation casts a negatively oriented shadow carrier. This projection becomes the localized electron only when interacting with a specific measurement readout protocol. The foliation index, lambda, organizes how this projection is sliced. Shifting the index alters the shadow state, containing zero chronological duration. The observable electron is a stable, tomographically mapped readout. It is a carrier, completely reliant on the underlying non-temporal source relation. If we strip away the Feynman backward time convention and refuse to invent a separate ontology of antiparticles, how do we rigorously classify the positron? We apply a charge conjugation operator directly to the lepton projection grammar. This generates the formal positron equation. The operator reverses the charge orientation and the additive quantum numbers in the shadow-readable sector. Notice what happens in counterspace. Nothing. The deeper source-level architecture remains completely single and structurally identical. The mass scale stays the same. Fermionic spin 1/2 constraints stay the same. Only the projection polarity has changed. Antimatter is the exact same source architecture read through a conjugated projection polarity. We can verify this projection grammar by shifting focus from isolated elementary readouts to complex composite bound states. Consider positronium, a system where an electron and a positron bind together. In diffraction readouts, positronium does not scatter like two opposing classical beads independently orbiting one another. Under the exact right experimental conditions, the constituent conjugate readouts lock together, forming a single, coherent, completely neutral projection structure. This hardware array belongs to the Alpha collaboration at CERN. They assemble antihydrogen, an antiproton bound to a positron, to test whether conjugate charge alters macroscopic interactions. They isolated these neutral anti-atoms and measured their motion under the influence of Earth's gravity. Pop science often speculates about a repulsive anti-gravity. The alpha data, however, showed consistent downward acceleration within experimental limits. Composite antimatter proves that both matter and antimatter rely on a shared, unified shadow gravity projection grammar. Internal charge structure can be inverted without requiring a separate gravitational ontology. The terminology of physics carries hidden assumptions. The word annihilation implies that matter and antimatter collide and erase each other from reality entirely. This text equation illustrates the standard notation for an electron and a positron interacting to yield two photons. We must replace this with the rigorous carrier transition formulation. The two conjugate charged readouts close perfectly into a neutral electromagnetic readability sector. Energy, momentum, and angular momentum dictate the transition. The invariant source accounting remains perfectly intact, only the shadow carrier mode changes. Antimatter is exclusively charge conjugate projection polarity within one source domain architecture. Analytical rigor requires discipline. We must stop mistaking the mathematical maps we draw for the physical territory we inhabit.